Workbook page 95, continuing lesson 7.2 on area of triangles. So we're given some vertices here and they're asking the area of the triangle. So this is a little bit different because we're actually graphing these points and then finding the area of the triangle. So if we graph these, we've got 4, 1. When you graph these, remember the first number is the x, which goes left to right. The second number is the y, which goes up or down like a yo-yo. So 4, 1, we've got 9, 1, and we've got 2, 5. So if you just draw those and then connect the dots. So once we've drawn this, then we're going to try to find the area. So we'll start out with our formula. Area of a triangle is 1/2 base times height. Then what we have to do is just count the squares to figure out what the base and the height are. So the base on this, we're looking at the bottom of the triangle. Think about it's from here to here. And this may be the easiest way for you to figure that out. If you just draw lines going down from those and then count the boxes in between it, that base is 5. Okay? Some people get confused sometimes because of the angle of how the triangle's going up from there. But if you just draw lines going down, that'll make it easier for you to keep track of that. So the height, we're talking about how tall the triangle is. If this was in a book, they would maybe have come with these dotted lines and showing a right angle. Again, it's essentially how tall, just straight up and down. And so if you count that, that's 4 units tall. So at that point, you got a couple of options. One option, since all these are being multiplied, you can multiply whatever order you want. So if you wanted to, you could say 1/2 of 4 is 2, and then 2 times 5 is 10. And this is going to be square units. You can write it like this if you want, or you can just write out the word square units. Other thing, you could take 5 times 4, which is 20, and then take 1/2 of that as 10. Either way is fine. Number 14, a gymnastics incline mat is shaped like a wedge. 2 sides of the mat are shaped like right triangles. How much vinyl is needed to cover both the triangular sides? So finding the amount of vinyl we need to cover this is going to be dealing with the area of a triangle. So 1/2 times base times height is how we find the area of a triangle. So if you look at the triangle, in my book it's got kind of the blue and yellow here. I know yours is not in color, so sorry for that. But base is 33 and the height is 15. This one, those are both odds, so if you want to take 1/2 of them, you can. 1/2 of one of them. Otherwise, if you just multiply that out, remember the 1/2 you can do is 0.5 if you're able to use a calculator for this. So that'd be 247.5 square inches. We haven't done anything wrong to this point. That is not, however, our answer to this problem. So that is just going to cover one of the triangles. So if we multiply that by 2, would cover 2 triangles, and that would be 495 square inches. A different option you could have done, I wouldn't go back and change it at this point, but another option you could have done is said from the beginning, I'm going to have 2 of these triangles. We could have put a times 2 here at the end. And then 1/2 of 2 is 1. If you multiply by 1, it's going to stay the same. So we could kind of think of the 1/2 and the 2 as canceling out. And then if you just do 35 times 13, that would give you your answer. So Again, just a couple options on how we can work that one out. Number 16, the area of a triangle is 36 square centimeters. Give 3 possible sets of dimensions for the triangle's base and height, and explain whether you can also give the side lengths of the triangles. So we've got several options for this. What we have to remember, the area of a triangle is 1/2 times base times height. So when they're saying the area is 36, the dimensions we pick, remember, we're going to be taking half of that, and we want it to equal 36. So one option, we could have 36 centimeters and 2 centimeters could be our dimensions, or 2 and 36. We'll consider that be the same. Another option, we could have 18 centimeters and 4 centimeters. Again, if we multiply those together, or just think about half of 18 is 9, and then 9 times 4 is 36. Or 18 times 4 is 72, and then half of 72 is 36. Ultimately, that's what we're after, is getting the base times height to be 72, so that when we take half of it, we get 36. Another option would be 9 centimeters and 8 centimeters then. Another option would be 12 centimeters and 6 centimeters. Another option would be 72 centimeters and 1 centimeter. Another option would be 24 centimeters and 3 centimeters. And again, all these could be switched around, and that would work out also. It's possible as well that we could have decimals. You know, we could have like 1/2 and 144 could work as well. And for this problem, we would not be able to tell what the side lengths of the triangle are. Technically, as you go on in math, if this were a right triangle, which we don't know that, if it were a right triangle, the base and the height would be 2 of the sides, and we would be able to figure out the third side. We'll learn about that maybe in 8th grade, but for right now, we're just going to say we don't even know what kind of triangle it is, so there's no way for us to tell for sure the side lengths, because the height, remember, the height could be just something inside the triangle, or if it's an obtuse triangle, the height could be out to the side here. If we look at number 18, we have a triangle. They are telling us the area is 117 square centimeters, and it says write and solve an equation to find the height h of the triangle GHK. So it says write and solve an equation. We better do that. So start out with your formula. So looking things over, if you look at the picture, the 26 centimeters is going to be the base. 1/2 automatically just comes down. Area is 117. We're trying to find the height. What we could do then, we could take half of 26, which is 13. At that point, we have 13 times h. If you divide by 13, then that'll come out to be 9 centimeters. So this gives us an idea of how to find the area of triangles.